Okay, so next up, let's go ahead and do part 2 and then take like a 10-minute break because I know this is a long class and I promised my students last semester that I would start taking breaks throughout. So I'm going to try to stick to that. So we'll get through this and then take a 10-minute break. All right, so next up are lists. Arguably one of the most important built-in types in Python because lists contain data and you're always dealing with some type of data, and lists, because they're ordered, also contain placement, right? So for example, we can create lists with the square brackets and place our elements in there separated by commas. Now, for those of you coming from MATLAB or R, this is not a vector or anything close to a vector. Python lists are very simple, non-mathematical arrays. I can't emphasize that enough. They're non-mathematical. They're just containers for data that is ordered in a way that you want it to be ordered. They are not vectors in any sense of the word. Okay, vectors we will cover next Friday when I introduce NumPy. So, but these are just simple ordered containers or sequences of data. So here is a simple list of numbers. Here is another list. Notice now that I can put in different types of values in here. So I can have strings, integers. This could even be like a floating point number. It doesn't matter. They can contain anything you want. In fact, they can be nested. So you can put lists inside of lists, which is essentially a matrix-like object. It's a multi-dimensional list. Okay. So if we just copy this here, come down and paste and run, we see that the things just spit out, right? And then notice here that the number list and the number string list are now the elements of the nested list, right? Okay, now, as I mentioned in the previous notebook, anytime you are dealing with sequential objects, you can find the length of them using the built-in length function. Okay, just come down here and run that. You'll see the number of items in this list is 6. Okay, and you can see that I passed the length function inside of the curly braces, and inside of that function, I passed the number list. Okay, and as you would expect, just like strings, we can index through with the indices of the elements in the list. Okay, and the indices start at 0 as before. Also notice that I'm starting to move faster, and as we go on, I'm going to be moving faster and faster. That's why I made these notebooks for you, so that you'll have this as reference when lecture ends. All right, so here's my sample list. There's link 4, all right? And then at the 0 index, we have the element A. At the 1 index, we have the element B, so forth and so on, okay? We can also do reverse indexing, okay? So if I copy that, we just have to remember that the very last element is at the -1 index. It's the most important thing to remember. Once you remember that, you can start scrolling around all you want and from the back or from the front, and it's really easy and I like it. So just like with strings, we can also slice, right? So again, remember the first element is inclusive. So the element at that index all the way up to this element, non-inclusive. So before I run anything, okay, what is sample list? So sample list, shift enter. So it's ABC, right? I mean, ABCD. So looking at this, before I run this code, what should this print out? So index 1, index 2, index 3. And we'd stop because this is non-inclusive. So let's go ahead and copy this and paste it. Shift enter. And we're good to go. We see that indeed it sliced through that list and it returned a list, right? In the previous string slicing, it returned a string. In this case, it's going to return a list, okay? Now, on to some numerical things, basic numerical things. Now, if our list is populated with numeric types, so these are either floating point values or integer values or even complex values, we can call several different functions on them.
Sorry, Professor, quick question. So in the slicing, did it return change the sample list, or and the sample list is now BCD?
No, it returns a new list.
Okay.
So we can verify that. In fact, all of you should probably make several cells underneath each of the cells that I run so that you can like double check what's going on. Right? So there's sample list, it hasn't been changed. But if I, and then you can like, maybe I should tell you to try this. What happens when you do this? Sample, no start, :3. Oh, sample list, I'm sorry. So see if you can go back and figure out what that means. And we'll revisit it later though.
Thank you.
Yeah. Okay, so when we have numeric types, we can call numeric specific functions such as sum, max, and min. These are built into Python and they're really useful. So for example, if this is our sample list here, oh, I'm making this a little bit fancy. So it's starting to move quickly, just a warning. I'm going to copy this and run it and then tell you what happens or describe to you what's going on. So, okay, so this is the output. I see that I have my sample list at the top equals to this. I see I have a separating line. And then I see the sum of the numbers is equal to that. The maximum is equal to this, and the minimum is equal to that. So how was that generated? Well, first off, I made a variable equal to the format string this. So what this does is it makes a string, and then it interpolates this value. It changes it. So sample list is equal to this. So that's what will appear in the string here. And that's how we get this first line here. Okay. So I assigned that to a variable to print it. But why did I do that? Well, I wanted underneath the print statement of that, I wanted there to be a line. So what's going on here? Can anyone take a guess?
So you're just inputting the dashes like in the length of the title.
Exactly.
And having
exactly.
a new line afterwards.
Exactly. So that's one thing we didn't cover in strings. If I take that string there and I multiply it by 10, look what it does. Right? You can, this just takes it and it makes 10 copies of it. So that was just my way of making a little bar to place underneath here that had roughly the same length. Okay, would appear the same. I wanted it to fit there. And again, because I taught myself with C and C++ a long time ago, and I've read especially this book called the C programming language. I have a lot of love for manipulating strings, and because those are the examples that these classic texts use. But also manipulating strings to do exactly what you want is no different than manipulating data, because strings are literally just ordered collections of characters which you can think of as data. So being able to manipulate strings and learning clever ways to solve problems you want to fix is important. And that's why I like doing it. Okay, so what's up next? I make my line, pass another F string, and then here, notice this is the sum function inside of there, right? So this just computes the sum of this list, and then the F string interpolates it and shows it as a string here. This function here, max, computes the maximum. This function here computes the minimum. Okay, and this is the output from all of this. And then notice, again, I make another line underneath it of this many dashes. Okay, so as junior data scientists, we now can do at least a little bit of statistical computation without having to add any libraries, because we have the sum function and then we also have the length function. So if we wanted to compute the average or the mean of our list, we can just sum our list and then divide it by the length. Okay, so then there's the mean of our list. And again, I'm passing this into a format string because I want to print out the data. You don't have to necessarily do that. Like for example, when I'm coding on my own and I'm just quickly like computing things, I would literally just do something like this. And it just would output that, right? Or actually, I know myself, I would just write a function to compute the mean on any list, but we'll get to functions later in the lecture. Okay. Okay, now as before, what's the most important thing about Python? Everything in Python is an object. and all objects have attributes and methods. Anytime you encounter a new object, you should probably look up the methods associated with that object and find any of the ones that might be useful for you. Here, I think this is actually a list of all the methods I know of. I'm pretty sure this is all of them. We have an append method, which adds elements to the end of the list. Clear removes the elements from the list. Copy makes a copy of the list. Count returns a number of stuff, all sorts of things. But real quick, this is different. Adds an element at the end of the list. That means that lists must be mutable. They can be changed, which is very different than strings, which we can't add a character onto a string. They're immutable. Lists are mutable, and that's a really important thing to know. And we'll learn more about that in the following code cells. All right, so let's use the append method and see what happens. All right, so if I copy this code and I paste it, so what's going on in this code cell? All right, so I instantiate, i.e. create an instance of a list, and then I print out my list. And then here, I call the append method, and I pass in apple. And then after I call that method, I print, again, sample list. So let's see what this does. So sample list before applying the append method is this. And then sample list after applying the append method. So now apple is at the tail end of the list. Appending is such a common method to use on lists that you'll be very familiar with how this works in a short amount of time. But I need to warn you.
I had a question.
Yeah. So we have these methods. We see that we've appended onto this list the string apple. Now we have to be careful now. Let's see what happens with this code. So I'm going to copy this. And this is because lists are mutable that we get this problem. So just as before, we define a list, we print the list, and then we apply append. But here we assigned x equals to this. Okay. And then when we try to print out x, we get none. Can anyone take a guess at why that's happening?
Because you're reassigning what x equals.
You're getting close. I'll go ahead and tell you for the sake of time. So what are methods? Methods on an object are functions, right? And this method here, what does it do to x? It modifies the list, right? That method modifies the list. That method does not return anything. Functions don't have to return values. So in this case, this method returns none. Even though it's modifying x, it's returning none. So what you're doing here is you're saying x is equal to none type or nothing, because this function is returning nothing. If I do that, everything's fine. But if I assign x to be this function is returning nothing, and it's just going to completely erase x. Something to keep in mind. Is that clear? Like you basically, you have to be careful when you're assigning variables to function calls, because those function calls might be just mutating an object instead of returning an object, right? And if you assign a variable to a function call that returns nothing, it's going to erase that variable. One more point of warning here is this behavior here. Okay, so if I copy this code, come down here and run it. All right, so again, here's x, and then I say, okay, y is equal to that list. I print out x, and then I want to append into y apple. Okay, that's fine. And then after applying the append method on y, I print out x. Okay, so, whoa, I'm printing out x, right? But I never appended anything to x. Do y'all see that? The reason for this is that assigning a new variable to a list variable does not make a copy. It does not copy it. It simply makes an additional name. So anytime you have a mutable object and you assign a new variable to that mutable object, you're not making a copy, you're assigning it two different names. So X and Y both are pointing towards this in memory. Okay. Now, if you wanted to make a new version of this, you didn't want to change the original and you wanted to change another one, you would have to use the dot copy method. So Y is equal to X dot copy. Now this returns a new list. It has a return value. I press Shift Enter. I see now that X stayed the same, right? Right there, there's X. And if I look at Y, it should be changed. Y is definitely been changed or altered. Okay. Next up, sorting. Sorting is one of the most common tasks that you will ever do with lists. And luckily, Python lists, question? All right. Luckily, Python lists have a built-in sort method. Okay, and this is a mutating method, so it mutates the original object that you're looking at. So here's my sample list. I print it out, and then I call the dot sort method, and then I'm going to print out sample list after calling that method. All right, so this was my original list, and then I sorted it, and now it's 2, 7, 9, 10 instead of this here. Again, super useful. But suppose we want to sort it as 10, 9, 7, 2. Well, that seems like a reasonable thing that we'd want to do. And if you think of it as something that you might want to do, there's a 99% chance that it's already built into Python somewhere. And one way that you can look at this is by calling the help function. Okay. Now, real fast, before I do this, I'm redefining sample list in each cell just so that you can run cells independent of each other. If you wanted, you could just have sample list defined way above, and then you never have to define it again. I'm just doing this so that you can run each cell one at a time. Okay. All right, so let's see what happens here. I call the help built-in Python function on this method. And I look, I see a star, we don't know what that is yet. I see a key, and then I see reverse. The reverse flag can be set to sort in descending order. Ah, good. So here with the help function, we see that we can set this flag. Flags are typically Boolean values. If we set this keyword argument reverse, it is a keyword argument because you see an equal sign in the function definition or method definition. So by default, it's equal to false right here. See that? So we're going to change that to be true and see what happens. So if I copy that list, paste, I Shift Enter. So this is the sample list before applying the sort method, and then applying the sort method with the keyword argument reverse equals to true, we get in this descending order, 10, 9, 7, 2. Okay. Now, another method that's common is extend. If we have two lists and we would like to kind of join them together, similar to string concatenation, we use the extend method. So these are two lists. On A, we call the extend method, and it's going to place B at the tail end of A, or each element of B at the tail end of A. So now that we know how that there's these methods, and there's even a count method, right? We can write a quick computation to find the probability of selecting some value from a given sample space S. So suppose our sample space consists of all of this, and we're just selecting out an apple. We can call sample space.count, and this is going to return the number of times apple appears in this list. If we know that, then we can compute the probability because it's just the number of times apple appears in the list divided by the cardinality of the total list. All right, so if I just copy this code here, and then paste, run it. And then that's the probability of selecting an apple. And it is 0.5, right? Because it's half of the elements in there. Now, tuples are the next topic, but it's really short to go through because tuples are immutable, they cannot be mutated, immutable versions of lists and are instantiated or created with parentheses rather than brackets. So pretty much everything that you can do on lists, you can do on tuples, so long as those things are not related to mutating. You can't append onto list, you can't change the lengths of lists. I mean, not lists, tuples. You can't append onto tuples, you can't add, do merging tuples together. Like, these are immutable versions of lists. But pretty much everything else is the same. So if you understand the basics of working with lists, then you'll understand the basics of working with tuples. Okay. So here we can't sort them because they're immutable. We can't change the ordering. They are fixed in place once you define them. But we can compute, for example, the length, sum, min, max. We can index through it just like before, and we can slice it. Okay, so just like before. They're just, if you want to store data in a very specific ordering, and you don't want that ordering or the values in that ordering to be changed, you store that data as a list instead of a tuple. Okay. Next up, and finally, this is the last type in this notebook, are sets. And sets in Python are defined in a similar way to the mathematical definition of sets, in that they are unordered collections of elements with non-repeating elements. There's no repetition of elements in unordered. And there are two ways to instantiate these types in Python. You can instantiate them with the curly braces, which looks just like a set you would see in a textbook, or you can convert a list into a set using the set function, which is built in. So if we just copy these guys here and then paste, we'll see that. Okay. Now, as I mentioned just a moment ago, sets do not have repetition of elements. So in this instantiation of X here, notice that A appears twice and C appears twice. So if I call print X, let's see what happens. The duplicates were removed. So sets really do contain unique elements in this sense. Now, from the point of view of data science and exploring data, this is actually really useful to look at like a quick one line of Python code to find the unique elements in a list of data. So for example, if data is equal to this list of numeric values, and I want to know what the unique values in there are, I can convert that list to a set, which will remove any repetition of values, and then convert it back to a list. So this is the first time you're seeing the list function, but we can convert sets back in the list with that function. Okay, so let's see what happens when we do this. We copy, we paste, press Shift Enter. Okay, so here's our original data set up top, and then the unique entries are here, and you see that that's correct. So this quick one-liner right here is an easy way to find the unique elements in a list, which can be especially useful when you're looking at large arrays of categorical data. So you have like large arrays of names of people, or larger arrays of like species of animals, or large arrays of like variations of virus, and you want to know what the exact values of the species, for example, or exact value of the names are in that array. Well, you just do this. You convert it to a set, remove the duplicates, convert it back to a list, and you have it right in front of you. Okay. Now, sets have operations that you might know of from your undergrad degree, such as the union of elements, the intersection, the set difference, the metric difference, and these all work as expected. Just now, you call them by way of set methods, right? So notice I haven't really mentioned what the set methods are. I'm just telling you about them. The reason for this is by now I hope that you understand that every object in Python, I mean, everything in Python is an object, and all objects have methods and attributes. So There's a list of them here if you want to see more about set methods, but these are the basics. And then if these are our sets here. If we do set dot union and then pass in another set, it will be the union. Set dot intersect, intersection of those sets, set difference, and then symmetric difference. And I encourage you to click here to learn more. Okay, now let's go ahead and take a 10,